Good morning, good afternoon, good evening, everyone. Today I'm going to talk about more machine learning papers that were recently published for this month. If you are going to review some of these papers, you'll notice that they are not focused on the oil and gas industry as much. Some of them are, some of them are not. But I thought these papers would be very interesting nonetheless. As usual, please be sure to like this video, subscribe so you can get more content in oil and gas and professional development topics, and please be sure to comment on the video below so I can incorporate your feedback into future videos. Please be sure to hit that notification bell when you do subscribe because I upload every Friday and every Sunday. Every Friday is a professional development topic, and every Sunday is a technical review. Well, let's get to the content. The first paper I'll talk about is a systematic evaluation of large language models of code. Large language models of code have recently been shown to tremendous promise in completing code and synthesizing code from natural language descriptions. However, the current state-of-the-art code language models are not publicly available, leaving many questions about their model and data design decisions. They aim to fill some of these blanks through a systematic evaluation of the largest existing models, and they meaning the authors. Although Codex itself is not open source, they find that existing open source models do achieve close results in some programming languages, although targeted mainly for natural language modeling. They further identify an important missing piece in the form of a language open source model trained exclusively on a multilingual corpus of code. They release a new model, Polycoder, with 2.7 billion parameters based on the GP2 architecture, which was trained on a 249 gigabyte code across 12 programming languages in a single machine. In the C programming language, Polycoder outperforms all models, including Codex. The trained models in open source are publicly available, and they provide the link. And I'll also provide the link in the description box as well. I strongly suggest you check out this paper just to look at how literature reviews are when it comes to machine learning papers. The next paper I'll talk about is Tensor Programs 5, Tuning Large Neural Networks via Zero-Shot Hyperparameter Transfer. Hyperparameter tuning in deep learning is an expensive process, prohibitively so for neural networks with billions of parameters. They show that, the authors, in the recently discovered maximal update parameterization, or MUP, many optimal HPs remain stable even as model size changes. This leads to a new HP tuning paradigm they called mood transfer. Parameterize the target model and MUP, tune the HP indirectly on a smaller model, and zero-shot transfer them to a full-size model. They verify mood transfer on a transformer and ResNet, for example, by transferring pre-training HPs from a model of 13 million parameters. They outperform the published numbers on a BRT large 350 million parameters with the total tuning cost equivalent to pre-training BRT large once. By transferring the 40 million parameters, they outperform published numbers of the 6.7 billion GPT-3 model with the tuning cost of only 7% of total pre-training cost. PyTorch implementation of the technique can be found, and they provide the location as well, which I'll also provide in the description box below. The third paper I'll talk about is restoring and attributing ancient text during deep neural networks, which I found pretty interesting. Ancient history relies on disciplines such as epigraphy, the study of inscribed text known as inscriptions, for the evidence of the thought, language, society, and history of the past civilizations. However, over the centuries, many inscriptions have been damaged to the point of illegibility, transported from their original location, and their date of writing is steeped in uncertainty. Hence, they present Ithaca, a deep neural network for textual restoration, a geographical attribution and chronological attribution for ancient Greek inscriptions. Ithaca is designed to assist and expand a historian's workflow. The architecture of Ithaca focuses on collaboration, decision support, and interpretability. While Ithaca alone achieves 62% accuracy when restoring damaged text, the use of Ithaca by historians improved their accuracy from 25 to 72%, confirming the synergistic effect of the research tool. Ithaca can contribute inscriptions of the original location with an accuracy of 71% and can date them to less than 30 years of their ground truth ranges, relating key texts of classical Athens and contributing to topical debates in ancient history. The research show how models such as Ithaca can unlock the cooperative potential between artificial intelligence and historians, transformationally impacting the way they study and write about one of the most important periods of human history. I thought that was a really interesting paper, and I suggest you check that one out. KUBRIC, a scalable dataset generator. Data is the driving force of machine learning, with the amount and the quality of training data often being more important for the performance of a system than architecture and training details. But collecting, processing, and annotating real data at a scale is difficult, expensive, and frequently raises additional privacy, fairness, and legal concerns. Synthetic data is a powerful tool with the potential to address these shortcomings. It is cheap, and it supports rich ground truth annotation, offers full control over data, and can circumvent and mitigate problems regarding bias, privacy, and licensing. Unfortunately, software tools for effective data generation are less mature than those for architecture design and training, which leads to fragmented generation efforts. To address these problems, they introduced KUBRIC, an open-source Python framework that interfaces with PyBullet and Blender to generate photorealistic scenes with rich annotations and seamlessly scales in large jobs distributed over thousands of machines, generating terabytes of data. They demonstrate the effectiveness of KUBRIC by presenting a series of 13 different generated datasets for tasks ranging from studying 3D NREF models to optical flow estimation. They released KUBRIC, the used assets of all the generation code, as well as rendered datasets for reuse and modification. The last paper I'll talk about is STYLENERE, a style-based 3D-aware generator for high-resolution image synthesis. This is a generative model for photorealistic high-resolution image synthesis with high multi-view consistency, which can be trained on unstructured 2D images. Existing approaches cannot synthesize high-resolution images with fine details or yield noticeable 3D inconsistent artifacts. In addition, many of them lack control over style attributes and explicit 3D camera poses. STYLENERE integrates neural radiance field into a style-based generator to tackle the aforementioned challenges, i.e. improving rendering efficiency and 3D consistency of high-resolution image generation. They perform the volume rendering only to produce a low-resolution feature map and progressively apply upsampling 2D to address the first issue. To mitigate the inconsistencies caused by 2D upsampling, they proposed multiple designs, including a better upsampler and new regularization loss. With these designs, STYLENERE can synthesize high-resolution images at interactive rates while preserving 3D consistency at high quality. STYLENERE also enables control of camera poses and different levels of styles, which can generate to unseen views. It also supports challenging tasks, including zoom in and out, style mixing, inversion, and semantic editing. That's all the papers that I wanted to cover for today. As usual, please be sure to like this video, subscribe so you can get more content in oil and gas and professional development topics, and please be sure to comment on the video below so I can incorporate your feedback into future videos. Thank you so much for taking the time to watch this video, and I'll see you in the next one.